The limitation of the spot reading test is that it's dependent upon time, temperature, and interpretation. Because the test item is charging and the readings are changing as the item goes to full charge, time is important, and the time at which the reading was taken influences the actual number that gets recorded. Temperature is also a factor. Temperature affects insulation notably and consequently has to be taken into account, and for record purposes typically adjusted to a common temperature base. And thirdly, you end up with a number. This could be anything covering an enormous range. On good equipment, it can range from megohms to terohms. So the operator is now left with the task of interpreting what that number means. And if you have a previous test result, that's made a lot easier, but if you don't, it puts an onus on the operator. Consequently, the next two tests that we're going to look at are time versus resistance tests. These eliminate the dependency on the time of the test, the temperature effect, and also they give you a figure of merit which helps the operator interpret the test results as to whether he considers them good or bad. The selector switch also has a timer function for the insulation resistance test if you wanted to set that up. And the next position after that is the dielectric absorption ratio, time versus resistance. And in this case, the tester will record values at two select times, which the operator sets up and designates on the setup menu. Typical values are 1 minute into 3 minutes or 30 seconds into 1 minute. The tester will automatically then run the test for that time. So we'll select that and we'll get it underway. And then at the end of the test, all the data is shown on the display. So it will show you time 1, it will show you time 2, and it will do the calculation for you in terms of the ratio. And the goal here is to look for a relatively high ratio, because insulation that's deteriorated will show relatively little charging effect but show a lot of leakage effect. Now remember, charging diminishes, whereas leakage stays relatively constant. So a test item that is pulling primarily charging current will show a much higher number at the end of a time test than it does at an earlier point. And when you create that ratio, you get a number, say like 3, for instance. That gives you confidence that the tester was mostly looking at charging current. If you have a lot of leakage, it stays relatively constant, it holds the curve down, and you will end up with a ratio that's somewhere around 1 point whatever. And that gives you, again, a convenient flag without having to actually work with the actual numbers to tell you that the test item is not in a great condition. Then, the most commonly used across the industry is the Polarization Index, which by definition is a 1 minute ratio into a 10-minute ratio. So again, a selector switch position goes to PI, you select your test voltage, and you incept your test and begin making your measurements. At the conclusion of the test, the tester will automatically stop the test, but the critical information will remain on the display for the operator to evaluate. It will show you what the resistance reading was and the leakage current at time 1, and again at time 2, which in the case of a PI is 10 minutes, and it will calculate out the polarization index ratio. So again, you want to look for a nice high number, somewhere above 2, 3, 4, along in that range. If you get a flat number, 1.2, something like that, 1 and a fraction, then that kind of indicates that the test item isn't in real good shape and may need some further examination.